So like I said, only thing we're adding today is graphing the rational functions, okay? So just a couple of quick reminders. As you take a look, reminder again, rational functions are fractional functions, okay? Rational functions are the ones that have fractions, basically one function over another. Okay? Just a reminder about that. Two very quick things about asymptotes. Remember, a graph never crosses a vertical asymptote. However, it is possible that you might cross a horizontal one. We're not going to deal with that yet. I told you every day we're adding something in. That's actually what we're going to add in tomorrow. Is how do you know if a graph crosses the horizontal asymptote? And if it does, how do I actually find it? Okay, we will add that in tomorrow. Okay? But just a heads up, vertical asymptotes never cross that. Then I gave you the orange sheet here, the graphing rational functions kind of cheat sheet to help you walk your way through this. And I told you yesterday, I put this in order of how I would do the problems. Okay, number one thing, find your horizontal asymptote based on this criteria. Tomorrow, after we talk about cross points, that would be the second thing I would do. Okay? For now, we're going to skip it and go right on to the next part. Then we get into factoring and identifying any points of discontinuity, any values of x that you cannot have. Okay? Any value of x that cannot equal. Once we know where we have issues, then we start to identify what the issue is. Is it a hole in the graph? Is it a vertical asymptote? What's going on? We'll go back over that again today. And then the last part, just finding a couple other points, x and y intercepts that are on there. Okay? We'll take all of that information, and like I said, today we'll put it on the actual graph. Okay? The back side of that worksheet looks like this, by the way. It's basically the same information. It's just a little bit more direct on some of the stuff. And therefore, if this makes more sense, that's why I put it on the backside. I almost didn't even copy it off, and then I thought, it's just worded a little bit differently. Some of the stuff is worded a little bit differently, and maybe this makes more sense to some people. So I decided to put it on there. If it helps, if this makes more sense, then use this. Okay? So just kind of a heads up. All right, let's get right into it. I've got two examples for you today. So here is example number one. We'll work our way through this one. And like I said, if you weren't here yesterday, this will take you right through exactly what we did. All right, so if you start right at the top of your orange sheet, we're starting with horizontal asymptotes. When we look at the original function, top heavy, bottom heavy, or a tie? Bottom heavy. Bottom is a quadratic second degree. Top is linear. It's only a first degree. So this is bottom heavy, which means you have a horizontal asymptote at y equals 0. Okay? You have a horizontal asymptote at y equals 0. You know that right away. And again, I think I told you yesterday, all of the stuff we're doing right now is to make limits, which is what we're going to eventually talk about, make more sense. This will make a lot more sense why y equals 0 after we talk about limits, okay? So for now, it's just kind of a rule that we're kind of following, but we'll get to the understanding once we get to the limits part of things, okay? So there's the first part. Normally, we would talk about the cross points next. Like I said, we're going to ignore that yet. We'll add that in tomorrow. So let's go straight into factoring, okay? Let's go to the next part. I'm going to leave the numerator alone, x minus 1, over. How do I factor the denominator? What does it factor to? X minus 1 and x plus 1. That is a difference of squares, which means you have conjugate factors, x plus 1 and x minus 1. And right now, before I do anything else, you should be able to tell me what the discontinuities are. What can x not equal? 1 and negative 1. That is coming. That's why you want to factor this, because now it's very apparent what x cannot equal, okay? So x cannot equal 1 or negative 1. Those are the discontinuities. Those are the problem points. And now we need to identify, is it two vertical asymptotes, which, by the way, is possible. You can have two vertical asymptotes. Is it two holes in the graph? Is it one of each? That's kind of what we're looking at. And if we continue, let's say we simplify here, the x minus 1 factors will cancel out, and you're left with 1 over x plus 1. So question then becomes, since x minus 1 is what canceled, what's happening at 1? There's a hole in the graph. When you've got factors that cancel, it creates a hole in the graph. And so at x equals 1, that's where we have a hole. How do I find the y-coordinate so that I can actually plot the hole in the graph? What do we do?
Plug it in.
Plug it in. Okay? Yeah, take the 1. Where do I plug it in? The beginning or the end? The end. If you plugged it into the beginning, you're going to end up with 0 over 0. You're not going to get an answer. And that's because you haven't canceled the factors yet. Once you cancel the factor, then you can plug it in and see what you get. Okay? So if I plug that in, we end up with 1/2. There's the y-coordinate for the hole in the graph. Okay? Which means if 1 is a hole in the graph, what's happening at -1? That is a vertical asymptote. It's always one or the other. It's either a hole in the graph or a vertical asymptote. Okay? If it doesn't cancel, that means it's a vertical asymptote. So we have x equals -1 is a vertical asymptote. And now, like I said, just to kind of guide us in our graphing, we're going to find a couple other key points, x and y intercepts. Remember, x-intercept is when what is true? When y equals 0. X-intercepts are when y equals 0. Okay? And again, because we said this yesterday, because you have fractions, a fraction will only equal 0 whenever the numerator equals 0. When is the numerator going to equal 0? Never. There's no values of x in the numerator. It's always going to equal 1, which means there is no x-intercept. Okay? None. The numerator will never equal 0, therefore there is no x-intercept. Okay? Another reason for that, at least to this point, by the way, you have a horizontal asymptote at 0, at y equals 0, which means there's no x values. The only time that would not be true is if you had a cross point, which we'll talk about tomorrow. Okay? Y-intercept is when x equals 0. And you can take 0, you could plug that into the ending function, or sometimes it actually is easier to plug it back into the beginning. Doesn't really matter. Either way, you'll get the same answer. And if I plug in 0 for x, what do I get? We get 1 for y. That right there, if you were not here yesterday, that's what we did. We stopped right there. We were just finding the information to kind of set up today. Now graphing this, okay? So now let's take the information and let's actually put it on a graph. So if we do that, y equals 0, horizontal asymptote right here at the x-axis. We have a hole in the graph. We've got the coordinates, so we can kind of plot the open hole in the graph at the point 1, 1/2. So we'll put that about right there. Vertical asymptote at -1. Like I said, there is no x-intercept because of the horizontal asymptote. And we can plot the y-intercept at the point 0, 1. We can put a point right there. And now the last step is to actually draw in the graph. As you draw in the graph, just a quick heads up. Yesterday I gave you kind of the parent function graph where it's the two curves. Generally, I will always tell you that the curves are either above or below the horizontal asymptote, not both. Okay? You have a curve either above or below. In this case, if I'm looking at the right-hand side, is the curve going to be above or below? It has to be above. That's why we found those points. You've got points on the graph that are above the horizontal asymptote. That means you know one of the curves is right here. Okay? So, let's sketch that in. Curve number 1, right here. There's your first curve. And now, off of that, we know the second curve, again, is either above or below the horizontal asymptote. Where do you think this one's going to be without having any points? Below, because it's always opposite. They always kind of alternate. If one over here is above, then the next one on the other side of the asymptote is going to be below. Okay? And so that graph will look something like this. And there's the graph of your rational function. including all asymptotes, points, open holes in the graph, all that kind of stuff. Quick heads up, I'm going to link this back to where we're headed again. I told you this yesterday. Really, we're doing all this stuff because of limits. And I told you a limit is really what is y approaching. If we go to infinity, let's say x is going to positive infinity, what is y approaching? What y value are we getting really, really, really close to? 0. Guess what? You just did a limit. Okay. The limit as x goes to infinity, y is approaching 0. Now let's say we're looking at the vertical asymptote. As x is approaching 0, let's say from the right-hand side, because we could approach 0 either coming from the right or coming from the left. Notice, one side the graph is going up to infinity, the other side the graph goes down to negative infinity. Again, that is something that always happens. As you approach a vertical asymptote, it either goes up or it goes down to positive or negative infinity. Again, we'll revisit that, but that's kind of the idea. Let me pause for a second. Anybody with questions? Anything not making sense? All right, one more problem then. Let's make it a little bit more complex than that one. Just algebra-wise, let's make it a little bit more complex. But graphing, it's kind of the same idea. Can't quite see it. I'll blow it up for you so you can see it a little bit better. A little bit harder factoring here. Not too bad, but a little bit harder factoring. By the way, remember, factoring-wise, anything factoring is on the board. Greatest common factor, difference of squares. In this case, you have a trinomial, but where a is bigger than 1. So you got to kind of work that out with the two sets of parentheses. You could have factor by grouping. All of that stuff is on the board in terms of your factoring. So don't forget about those strategies. First question. Horizontal asymptote. Let's start there. Top heavy, bottom heavy, or tie? Tie, which means y equals, in this case, 2. You are looking right here. You're looking at the highest degree terms. And therefore, because it's a tie, you use the coefficients. 2, and technically there's a 1 over there. Okay? So your first thing you're writing down, horizontal asymptote, at y equals, let me put that back, at y equals 2. Okay, now to identify any holes, asymptotes, that kind of stuff. Let's go to the factoring part. So we have a trinomial that we are trying to factor. Refresher again. Remember, factors of the first term, which means this has to be 2x times x. Okay? There are no other factors that we have. Factors of the last term has to be 3 and 1. And now we just have to find the right combination, okay? And so I'm going to do it right away. I'm going to put the 3 there and the 1 there. The reason why I know that is correct, remember, in order to get the middle term, it's the combination of the inside, which is 1x, and the outside, which is 6x. 6 and 1. I need a negative 7 out of those, which means both of them need to be negative. Both of them are negative. Questions on that? Doing okay? Coming back to you, hopefully. And let's look at the denominator. How do you factor the denominator? This is a greatest common factor. Pull an x out, which leaves you with x minus 3. And again, as soon as you factor, you should be able to identify what x cannot equal. What are the issues for x?
3.
Or?
0.
Or 0. Yep. 3 coming from this factor, 0 coming from the x. Okay, so you've got 2 problem points, two points of discontinuity. And now we identify what those, which one is which. In this case, we do have x minus 3 that's going to cancel, which means what's happening at 3? There's a hole in the graph. 3, comma, something. We'll find the y-coordinate in a second. Simplified version, 2x minus 1 over x. Still have that left behind. Which means if 3 is a hole in the graph, what's happening at 0? It didn't cancel, therefore, a vertical asymptote. Yep. Did not cancel, it's still a problem. Therefore, that is where you have a vertical asymptote. X equals 0. And let's find that y-coordinate. If we take 3 and I plug it in, what do we get? Looks like 5/3. There is the y-coordinate of the hole in the graph. All right, and now, only thing left. Let's find a couple other points to help us. X-intercept, when y equals 0, which we said when you're dealing with fractions, is whenever the numerator equals 0. When does the numerator equal 0? Yeah, 1/2. Set the numerator equal to 0 and solve. So we have an x-intercept of 1/2, 0. And how about the y-intercept? If I plug in 0 for x, what do I get? A problem, right? It's undefined. There is no y-intercept because x can't equal 0. There is a vertical asymptote at x equals 0. Therefore, you can't have a point there. Okay? So there is no y-intercept. Okay, there again, there's what we did yesterday. Now let's take the information and put it on the graph. Okay. So y equals 2, horizontal asymptote. There's the first part. We can put the hole at 3. 5/3 is 1 2/3, so it's just below the horizontal asymptote. We are about right there, somewhere in that vicinity. X equals 0. That's the y-axis. There's your vertical asymptote. X-intercept, we can plot that. 1/2, 0. We can put that point right there. And now we're ready to put the graph. Tell me where one part of the graph is located. Bottom right corner. Yep. To the right of the vertical asymptote and below the horizontal. That's why those points will help us. That's why we find the x and the y-intercept and the holes in the graph to kind of guide us a little bit. So here is curve number 1, which means where is the other curve? It's in the opposite. Yep. Which means top left. There is curve number 2. And let me ask you a limit question. Only to, again, keep setting things up. As x goes to infinity, what is y approaching? As x goes to infinity, what does y approach? 2. It's approaching the horizontal asymptote. Again, you just did a limit. Okay. Nice part about limits, by the way, you're going to really like those assignments. Because when I give you a graph like this and I say, what's the limit as x goes to infinity? All you have to write down is 2. And you move on to the next problem. Okay, there's not a lot of work to show. It's just understanding the concepts. So like I said, when we get to that point, you're going to appreciate those assignments because it's pretty quick. Okay. How are we doing? Any questions? Otherwise, I'm going to get out of your way. You have an assignment from yesterday, again, where if you're not done with that one, that is where you should start. Get that done. Get that turned in. Otherwise, I have another assignment for you. It's only 6 questions. This one is where you are actually graphing. And you've got the rest of the time today to work, ask questions, help each other out, and we'll go from there.